Hi, welcome to ASVAB practice test, mechanical comprehension, lesson 5. So here today our first problem is a box with a mass of 10 kg is being posed along a flat surface with a coefficient of friction of 0.4. Calculate the force needed to move the box at a constant velocity. So here is a surface and box is 10 kg. So 10 kg times 9.8 is the gravitational force meter per second square will move. So here is the friction force F S equals to 0.4. So your friction force will be counted as mu s. So here we need to write down like this way, mu s equals to 0.4. So we need to find out the value. We need to find out the velocity, constant velocity. So Fw equals to mu s times the weight Fn. So here 0.4 times 10 kg times 9.8 equals to 98 Newton. So now we need to calculate like 4 over 10 times 98 equals to here Newton, and 10 if it goes over 98 it will give me 4 times 9.8 Newton equals to 4 times 8 equals to 32. Here 2 will come and 3 will carry, and 4 times 9 equals to 36 plus 9. 36 plus 3 equals to 39. 39, here 1 decimal will become before one digit. So it's a 39.2 or decimal 2 Newton will be the answer. So here's our second problem. A 5-meter long beam weighs 200 Newton and is supported at both ends. If a 100 Newton weight is placed 1 meter from the end, where should a second 50 Newton weight be placed to balance the beam? So here 5-meter long beam. So here L load equals to 5 meter. So 5 meter divided by 2 equals to 2.5 meter. It's a effort arm, effort arm. So here is supported at the both end. If a weight, so W. So here we're going to find out the W2. So W1 equals to 100 Newton and L1 equals to 1 meter. W2 equals to 50 Newton and L2 equals to. So here we need to find out the value of L2. So now we need to place like this way, W load and L load, ER, effort arm, plus W2 L2 equals to W1 L1. So now come to calculate. So here first will come 200 Newton times 2.5 meter plus W2, and W2 is 50 Newton times L2. Here 100 Newton times 1 meter. So here we will get like this way. So wait, I need to calculate. So now we need to calculate like 200 times 2.5 equals to 500 Newton meter plus 50 L2 plus equals to 100 Newton. So here it's 50 L2 equals to 100 Newton meter minus 500 Newton meter. So here 50 L2 equals to 400 minus 400 Newton meter. So here L2 equals to 400 Newton meter over 50 Newton. So we will get value minus 8 meter. So it's minus 8 meter means from the left side. Left side we need to shift 8 meter. The L2 is 8 meter. We need to shift the 50 Newton weight to balance the lever. So this will be the answer, 8 meter. So here, where should a second 50 Newton weight be placed to balance the beam? So it's 8 meter from the left side. Okay, now come to another problem. Here, side of a cube with a side length of 2 meter is floating water. Its density, if the density of the water 1000 kilogram per meter cube, what is the weight of water displaced by the cube when it's floating? So here W equal to rho Z Ace. So rho equals to 1000 kilogram per meter cube. Here we have a value G equals to 9.8 meter per second square, and Ace equals to 2 meter. So we will get like 1000 times 9.8 times 2 meter. So it's 9800 times 2 Newton meter, or joule. We can convert it as joule. So it's 98 times 2. 98 times 2 equals to 196. Yes, 196 joule will be the answer. This is the third problem. So here, problem 3. A cube with a side length of 2 meter is floating in water. If the density of the water is 1000 kilogram per meter cube, what is the weight of water displaced by the cube when it's floating? So here we need to find out like W equal to rho G Ace, or rho VG, rho VG. So here we have a 2 meter one side, so V equals to L cube. So 2 meter cube, it's 8 meter cube. So here rho equals to 1000 kilogram per meter cube times 8 meter cube times 9.8 meter per second square. So now we will get here 1000 times 9.8 equals to 9800 kilogram meter meter square, meter square per second square. Here, and there is so here meter cube per meter cube, and meter here meter square, and here second square times 8 meter cube plus equals to. So here problem number 3 is a cube with a side of length 2 meter is floating in the water. If the density of water is 1000 kilogram per meter cube, what's the weight of the water displaced by the cube when it's floating? So here W equal to rho V and G. So V equals to 2 meter cube, your 8 meter cube, your rho equals to 1000 kilogram per meter cube, and G equals to 9.8 meter per second square. So your 1000 kilogram per meter cube times 8 meter cube times 9.8 meter per square equals to 1000 times 9.8 equals to 9800 kilogram meter square per meter square per second square times meter cube. So here we need to multiply. So 8 times 8 equals to 64. 4 will come, 6 will be carry. 8 times 9 is 72. 72 plus 6 equal to 78. 78,400 kg meter per second square. So it will be the answer. So 78,400 Newton. 400 Newton will be the answer. So now come to another problem is here. A column of water is 10 meter tall. Calculate the pressure of the bottom of the column. So here W equal to rho GS, so 1000 kilogram per meter cube times 9.8 meter per second square times 10 meter. Here we're going to find out the pressure. It's a pressure. So here we need to calculate, like it's a 9800 kilogram. Here meter per meter cube and meter. So meter per meter square and per second square times 10 meter. So here 10 meter. So we need to multiply. So multiply with 10 equals to 98,000 kilogram per meter per second square. So if we divide by 1000, it will 90 atmosphere pressure. Atmosphere will be the unit for pressure. So 98 atmosphere atm, or this will be the answer finally. So another problem is here. So a spring with a spring constant of 200 Newton meter is compressed by 0.5 meters. So it's a spring. So when we compress, it's like here, it's 5 meter, 0.5 meter. So we need to calculate. So F equal to Kx, K equal to 200 Newton per meter times 0.5 meter. Okay, so 200 times 0.5 equals to 100 Newton will be the answer. What is the force exerted by the spring? 100 Newton. So thanks for watching this video. Hope our fourth and the third problem will be helpful for you. This types of problem comes on the test, ASVAB test. So you will get these types of problem in your WARE or restive test also. So thanks for watching this video. Hope this video will be helpful for your test preparation. Goodbye for now. Please like, share with your friend. Hope this will be better for them. Goodbye for now.